Hi, hello everyone. Dear students, this is the third video of current electricity. Dear students, in previous video of this chapter, we will discuss what are the statement of Ohm's law and what are the limitations of Ohm's law and ohmic devices and non-ohmic devices, and also discussed the example for ohmic devices and example for non-ohmic devices. Just we will recap that, dear students. Statement of Ohm's law is uh, current in a metallic conductor. For example, I am taking this is one metallic conductor. In this metallic current, for example, this is one metallic conductor. For example, I amount of current is flowing in this metallic conductor. For example, I am taking this is the metallic conductor, and I amount of current is flowing in this conductor means this current in a metallic conductor is directly proportional to the potential difference applied across its ends. For example, students, I am taking this is the one end and this is the one end. In between these ends, suppose V amount of potential difference is applied between these two ends, and this I is directly proportional to this I is directly proportional to the V means potential difference applied across the ends of these conductor, and I is the current in a metallic conductor, and current in a metallic conductor is directly proportional to the potential difference applied across its ends. But the students, the condition is provided the temperature provided the temperature and other physical conditions of these conductor are kept constant. For example, I is directly proportional to V. Suppose temperature is changing when measurement is taking, means if the variation of temperature occurs means this law is not applicable. Only this law is applicable. Temperature and some other physical conditions are constant means then only Ohm's law is applicable. Once again, I is directly proportional to V. V means potential difference applied across the ends of the conductor. I means current in a metallic conductor. Current in a metallic conductor. And this law we can write. I is proportional to V. Here proportionality constant is there. This proportionality constant will gives the resistance of that conductor. This proportionality constant will gives the resistance of the conductor. Now I equal to V divided by R. R is called as the resistance of the conductor. V means potential difference applied across the conductor ends of the conductor. I means current in a metallic conductor. Using these two, we can write one more formula. Using this equation, we can simply write V equal to IR. V equal to I into R, product of current and resistance, that gives the potential difference applied across its ends. Now the students, limitations of this law means this law is not applicable for semiconductor. First one, this law is not applicable for semiconductor, and second thing is it is not applicable for superconductors. It is not applicable for superconductors. And third one is it is not applicable for vacuum tubes, and fourth one is it is not applicable for a metallic conductors at very low and very high temperatures. These are the four limitations of Ohm's law. These four. Dear students, in case of semiconductors, what will happen means semiconductor means the property lies in between conductors and semiconductors, as conductors and insulators. So initial temperature or very small temperature, it acts like an insulator. And that case, I is directly proportional to V. It is not possible. So in case of superconductor also, and in case of vacuum tubes, and in case of metallic conductors at very low and very high temperature. Now The question is, how does the resistance of a conductor depends on applied voltage? Resistance of a conductor is independent of applied voltage. Now the student, here V means potential difference, but it is independent of applied voltage. Resistance of a conductor is independent of applied voltage. Now the student, in previous video we will discuss what are the ohmic devices. The devices which obey the Ohm's law are called as ohmic devices. Okay, here it is. The devices which obey the Ohm's law are called as ohmic devices, and the devices which does not obey the Ohm's law are called as non-ohmic devices. And example for ohmic devices means metallic conductors, voltmeter and ammeter. And example for non-ohmic devices are semiconductors, triodes and diodes. Triodes and diodes, these are the types of semiconductors, and we will discuss in later videos about this. And one graph is there, students, here I versus V graph is there. I is current in a conductor or metallic conductor. V means potential difference across the conductor. Now this graph will linearly increasing. I increases means and V is also increasing, and V is increasing. This graph, linear graph, indicate that I is directly proportional to V. Now okay, the students, this graph is there. Now we'll discuss resistance of a conductor. Now students, we know formula, just written it is, we know this formula V equal to IR. Using that we can easily define the resistance. Okay, we know already V equal to IR means now we are defining resistance, and this implies by using this formula we can write R equal to V divided by I. R equal to V divided by R. Here V means potential difference and I means current. Resistance equal to ratio of potential difference applied across the current conductor per unit electric current. Per unit electric current, that gives the resistance of a conductor. Now we'll discuss that one. Now the students, a definition of resistance of a conductor will discuss. It is defined as the ratio of potential difference, applied across the ends of the conductor to the current flowing through it. Now it's very simple. R equal to V divided by I. This is ratio of V divided by I, that gives the resistance of a conductor. Now simply one more definition is there. We can simply define the resistance. One more factor is there, we will discuss. Now what will happen in case of conductors? For example, I am taking, this is one conductor, and number of electrons are moving, means electrons are flowing. That flow of electron will give the current. When current is flowing in the conductor means what will happen here? Some positive ions are there in the conductor or that metal. These fixed positive ions will oppose the flow of these electrons, and the movement of electrons can be opposed by these conductor, or in this conductor we have fixed positive ions. That fixed positive ions will oppose the flow of these electron, and that amount of opposition, that amount of opposition offered by a conductor, to the flow of electric current, through it is called as resistance of a conductor. Now the very simple and SI unit will discuss now. SI unit of resistance is ohm. The symbol is like this. This is the ohm, or simply we can write in terms of word means ohm it is. SI unit of resistance is ohm. Now we can easily define the definition of 1 ohm. Now the formula is there here. R equal to V divided by I. Suppose if V equal to 1 volt and I equal to 1 ampere, then R equal to 1 ohm. V equal to 1, I equal to 1, and R equal to 1 divided by 1, that gives 1. Now we can simply define resistance of a conductor is said to be 1 ohm. resistance of a conductor is said to be 1 ohm if 1 ampere of current 1 ampere of current flow through it when a potential difference of 1 volt is applied across its ends. That gives the 1 ohm. Very simple. 1 ohm equal to definition of 1 ohm. The resistance of a conductor is said to be 1 ohm. R equal to 1 ohm. When it is possible, when 1 ampere of current is flow through it, when a potential difference of 1 volt is applied across its ends. That gives the definition of ohm. And now we'll discuss what is the circuit symbol of resistance. Okay, SI unit of resistance is ohm, and what is the circuit symbol? Okay, this is the symbol of SI unit of resistance, and it is denoted as this sigma, and it is called as ohm. And definition also discussed. And now we'll discuss circuit symbol of resistance. The circuit symbol of resistance is this one. Okay, this is the symbol. Okay, now we'll discuss next topic. And origin of resistivity, how resistance will come. Okay, dear students, just only I explained this one. Once again I am discussing. For example, in this chart, in this photo, sorry, in this video, in this diagram we are observing electrons are flowing. Okay, now we are applying V amount of potential is applying between these two conductor ends of the conductor. I amount of current is flowing in this direction, and free electrons, dotted lines indicate the free electrons. That free electrons are moving. Sorry, one, this dot indicates free electron, and remaining holes are there. These are called as ions or atoms, and these free electrons are moving means current is flowing in this direction means electrons are drifting in opposite direction. These free electrons, the movement of these free electrons will be stopped by these ions or atoms. That is the origin of resistance or resistivity. Suppose if the temperature of this conductor increases means automatically number of free electrons will increases means this atom will break off and that gives the free electrons, and ions also break off will takes place, and that gives the same again free electrons. Number of free electrons increases means automatically resistance will be decreases. And the main thing is when the free electrons are moving means here it is, electrons will move through the conductor means they collide with the fixed positive ions or atoms free with the free electron. This opposition to the movement of free electrons is the origin of resistance. Okay, now we'll discuss next topic. One question is there here. We'll discuss a wire is carrying a current. Is it charged? Okay, student, suppose one wire is there and this wire is charged. Yes, this wire, is it charged? It is having current. Suppose I am taking one wire, this is wire, and it has I amount of current. Is it charged? No. The current in a wire is due to flow of these electrons only. The flow of electrons will give the current, but the number of protons in the wire at any instant is equal to the number of electrons. Hence charge on the electron is equal and opposite to that of the proton. Hence net charge on the wire is 0. Now what will happen actually, if this is the conductor means in this conductors electrons are moving in this direction means protons are moving in this direction. Protons are moving in this direction. Electrons have a negative charge, protons are positive charge, and number of electrons and number of protons, these two are equal. Hence the total charge will be 0. Hence a wire carrying current means it does not charged, it is. Okay, next we will discuss. Next topic is factors. This is very important. This question is asked in 2018 examination. Now this is very simple. We will discuss. Now this is very important question. This is asked in 2018. Okay, we will discuss that one. Now what are the factors? On which resistance of a conductor depends? This is very important. Now see, students, resistance of a conductor means R. R is directly proportional to the length of the conductor, and second one, R is inversely proportional to the area of the conductor. Fourth one, it depends upon the nature of the conductor, and fourth one, it depends upon the temperature. In simply I am writing resistance of a conductor depends on four physical terms or four physical terms. That one, first one, resistance of a conductor will depends upon the L, length of the conductor. For example, I am taking this is L is the length of the conductor. Okay, now R amount of resistance will be there in this conductor. For example, this length will be increasing. For example, this side length and this side length I am increasing. Okay, length will be increasing. I am writing this is delta L, increasing in length delta. Automatically resistance also increases. Just I am writing it is plus R. So it is directly proportional. Length increases means directly R also increases, and it depends upon the area of cross section of the conductor. For example, this is the conductor having area A. This is A and this is also area. For example, this area increases means what will happens to the conductor? What will happens to the conductor means area increases means resistance of a conductor is inversely proportional to its area. Area increases means automatically resistance will be decreases. Now third point is it depends upon the nature of conductor. Nature means for example, in metals means Fe is there, ferrous is there, for example magnan is there, and constantina is there. Okay, we'll discuss these two. These are the important alloys we'll discuss. And different elements having different resistance, because it depends nature of different elements. Different elements having different nature, so the resistance also different. So the nature of metal changes means automatically the resistance also changes. And fourth factor is it depends upon the temperature of the conductor. Resistance or this value is directly proportional to temperature in case of conductors. In case of conductor, resistance is directly proportional to temperature. Temperature increases means automatically resistance also increases in case of conductors or metal. But in case of semiconductors, it is inversely proportional. In case of semiconductor, R is inversely proportional to 1 by T. Temperature increases means resistance will be decreases, or temperature decreases means resistance will increases. So remember again, same thing, two questions are there, we will discuss that questions. Now how does the resistance of a conductor vary with its length and area of cross section? Dear students, just only we discussed resistance of a conductor is directly proportional to length of the conductor. R is directly proportional to L, and second one is inversely proportional to area of cross section. R is inversely proportional to area of cross section. Right? Okay students, next we will discuss one more topic. Okay, now we will discuss one more question is there. Okay students, here one more term will come, we will discuss that one. Next we will discuss resistivity. What is the resistivity? Resistance is discussed, now we will discuss one more topic, resistivity. Now students, resistance means we know already R equal to R is directly proportional to length of the conductor, and R resistance is inversely proportional to area of cross section of the conductor. Now this proportionality constant is there. That proportionality constant will gives the one more symbol, one more constant symbol, that is denoted as rho. Rho means here resistivity. Okay, this is equal to, next one more formula we are getting, this is R equal to rho L divided by A. Okay, already L means we know length of the conductor, A means we know area of cross section of the conductor, and rho means resistivity of the conductor. Rho means resistivity of the conductor. Okay, same thing here. This is there, R equal to L divided by R equal to R proportional to L by A and R equal to rho L divided by A. Okay, now we can define resistivity. Very simple. By using this formula, I am writing rho equal to A into R, cross multiplication. I am writing it is R into A divided by L. Okay, easily we can define what is the resistivity. Means here resistance is there, A is there, L is there. The ratio of A divided by L at R, that gives the resistivity. Means resistance R is there, resistance offered by a conductor, of unit area of cross section per unit length, unit area of cross section per unit length, that gives the resistivity. Resistivity of a conductor means resistance offered by a conductor per unit area, per, per unit area of cross section per unit length, unit area of cross section per unit length, that gives the resistivity. Now we'll discuss what are the factors which depends upon the resistivity. So before that we will discuss mm, discuss SI unit of resistance. Dear students, we know already SI unit of resistance was discussed, sorry, and SI unit of resistivity is, we will discuss what is the SI unit of resistivity. Okay, we know already SI unit of resistance is ohm, SI unit of resistance is ohm, and SI unit of resistivity is ohm meter. Okay, here it is ohm meter. Mention the SI unit of resistivity. SI unit of resistivity is ohm meter. Now we'll discuss next topic. Okay, all these things are there, and this is directly proportional is there. Okay, next we'll discuss next. Okay, now we'll discuss one note is there, sorry. Okay, here one question is there. A wire of resistivity rho is stretched to 3 times to length. What will be its new resistivity? Okay, one question is there, very simple question. This question is asked for knowledge. For example, students, this is the one wire is there, and this is stretching, means this side is stretching and this side is stretching 3 times. Okay, 3 times it will be stretching. And for example, initially having resistivity rho, after this increasing or stretching of this wire, what will happens to the resistivity? Rho dash equal to question mark, what will happens to the change in resistivity? So students, we know resistivity does not depends upon the length. Okay, resistivity does not depends upon the length, and also resistivity does not depends upon the area. You remember this thing, students? Resistivity of a conductor is independent of its length, whatever be the length. I am writing rho, it does not depends on the length, also it does not depends on the A, it is independent of L and A. If length of the wire increases means resistivity will be same, length of the wire decreases means resistivity is also same, area of cross section of the wire increases means resistivity will be same, area of cross section of the wire decreases means resistivity will be same. Now the question is, what factors on which the resistivity depends? Means it depends on the temperature. Resistivity depends on the temperature, and that resistivity of a metallic conductor is directly proportional to the temperature. Directly proportional to the temperature. Resistivity of a metallic conductor is directly proportional to the temperature. R is directly proportional to temperature, or rho is proportional to T. Resistivity is directly proportional to T. And one more formula is there, I will discuss that one. That formula is, we can write in terms of coefficient of temperature coefficient of resistivity. We will discuss that formula is, we can write rho T equal to rho naught into 1 plus alpha T. This is the formula. Okay, here rho naught T means resistivity at temperature T. Sorry, rho T means, and rho naught means resistivity at temperature 0 degree Celsius, and 1 is a number and alpha is there. Alpha means temperature coefficient of a resistivity. Alpha is temperature coefficient of a resistivity. Now we will discuss next topic on this. Now temperature coefficient of these two metals, this is very important because in practical we are using resistance box or resistance coil. It is also called as resistance coils, and that resistance coils are made up of these two elements. One is called as magnen and another one is called as constantan coils, and these two coils are making by making standard resistors using these two magnen and constantan are used for making standard resistors or resistance boxes or resistance coils, because temperature coefficient of these two metals is very low. Means it does not react if the temperature changes, means it does not changes. So magnen and constantan are used for making resistance coils. Now the question is, how does the resistivity of a semiconductor vary with temperature? Resistivity of a semiconductor is inversely proportional to temperature. Students, we know in case of in case of resistance also, resistance is directly proportional to T of for conductors, and resistance is inversely proportional to temperature. In case of insulator, same thing, resistivity is directly proportional to temperature in case of conductors, and resistivity is inversely proportional to temperature in case of semiconductors. Okay, this now we'll discuss two graphs are there. I will discuss, and very simple graphs are there. Okay, now see the this curve will indicate the this curve shows this curve shows that temperature increases, resistivity also increases. Now see, this is the temperature and this is the resistivity, and resistivity is increasing means temperature is also increasing, and some gap is there. This gap, in this gap, resistivity the conductor will acts like a insulator. Okay, right. Now I'll discuss one more graph. Same thing, this graph will gives the variation of temperature versus resistivity. Here also this graph is increasing linearly. This graph is increasing linearly. Linear graph is there here. This curve shows that temperature increases means automatically resistivity also increases linearly. And one question is there here: does the value of temperature coefficient of a resistance always positive? Students, temperature coefficient of a resistivity, resistance coefficient of resistance alpha does not no, it always, the question is it is always positive? No, because the value of temperature coefficient of resistance is positive for metals and alloys, and it is negative for semiconductors. Okay, in case of metals and alloys, it is positive, alpha is positive, and in case of semiconductors, alpha is negative, right? Okay, now the question is, the students, I think this is lengthy video. Today we will stop here only. Thank you for watching. And the students, I am making continuous videos on this chapter. Just watch and subscribe the video. Thank you for watching.